Let's now solve a few exam questions regarding this last lesson on statistics, the first of which is this question 2. This question 6. This is a June 2009 paper 6. And the question says this. During January, the numbers of people entering a store during the first hour after opening were as follows. And here you have all the information. You have here class intervals for the time after opening in minutes. You have here the frequency for each class interval. And you actually do have here already a column for the cumulative frequency. In some cases, you have to build this yourself. The table ends here, but in this case, you already have something about that. But as you notice, you have here some letters, an A and a B. And actually, the first question is for you to find the values of A and B. So how do you get this A? A is on a cumulative frequency column. So how do you get this? Cumulative frequency. Cumulative frequency is always calculated by adding to whatever you already had on a previous line, the frequency on the next one. So you start obviously with the same frequency on the first line. So on the second line is going to be this plus that. On the third line is going to be this plus that, and so forth. So what's going to be here on this line is going to be this plus that, 422 plus 72. What about this one? This one, you just have to look at this value over here and subtract whatever you got on A. And this is going to be the value B. This is exactly what I did over here. It's not this question, it's this one over here. And here you have the values. I've put this horizontally instead of vertically. And I have here the values. For A is 494 and for B is 46. Next question asks you to draw a cumulative frequency graph to represent this information. Take a scale of 2 centimeters for 10 minutes on the horizontal axis and 2 centimeters for 50 people on the vertical axis. Obviously, for practical reasons, I cannot follow exactly this scale. But anyway, you would, following those instructions, you would have anyway end up with something like this. All right. I have here 1, 2, 3, 4, 5 points corresponding to the 5 points that you have here. So the cumulative frequency on the vertical axis. And here the class intervals over here. After getting these points, you have to do a freehand curve that passes through them, and it will be something like this. Use a graph to estimate the median time after opening that people enter the store. Once you have a cumulative frequency graph, it's very easy to get the median time. How? Just look at the maximum value. It's 440, if you remember from the graph. Half of that is going to be 270, spotted here on the cumulative frequency line. It's over here. Then draw a horizontal line until you meet the graph. Then go down and estimate that value over here. Using my rough sketch, this will be 13 minutes. But I think that if you do this according to the rules that I mentioned, you would still get a similar value. Then calculate estimates of the mean m minutes and the standard deviation s minutes of the time after opening that people enter the store. In order for you to get this, you have to apply the formula. And to apply the formula, you need to get values of x. If you notice a little while ago, I added a line that you didn't have on the original paper. You didn't have, in this case, a column that I did over here. That will allow you to calculate the mean. And this column is the column in which you have the midpoint of each class interval. So for this one, it will be 5, for this one, 15, so forth. And once I have that, I can apply the formula for the mean, right? So is 5 times 210 plus 15 times 134 plus 25 times 78, etc. The whole thing divided by 540. And this would be 18.2 minutes. You can do something similar for the standard deviation. Pay attention, again, that for the standard deviation, you have to use the value of xi squared, but you can plug it in a calculator altogether, and then just follow the expression, subtract the mean that you already got squared, and you have the value of 14.2 minutes. Finally, use your graph to estimate the number of people entering the store between m minus 1/2 of s and m plus 1/2 of s minutes after opening. What is this? This is the mean, and this is minus half of the standard deviation, and the key, and here is the mean plus half of the standard deviation. How much is that? This is 18.2 minus 14.2 divided by 2, which is 11.1 minutes. Here you just have to add that, which yields 25.3 minutes. And then you have to use the graph, as the question says, to get that interval. And here you have the 11.1 minutes. Go up until you find the graph, then go left. And this is more or less 230. And then for the other one, 25.3, spot it over here, go up until you meet the graph, go left, and you get 400. Again, that's using my graph, but I trust that in yours you will have a value much different from this one. That's why this is an estimate question and not a calculate or determine question. One minus the other, you have 170 people. And that will be it for this paper, which, as you can see, is not complicated at all. And if you would do everything correctly, you would have 6, 12, you'd have 14 points with this question only. Let's look at another one. This one. This is from spring 2010, question paper 61. We're looking at question 2. The numbers of people traveling on a certain bus at different times of the day are as follows. And here you have a bunch of information about that. You have to draw a stem and leaf diagram to illustrate the information given above. If you look at these numbers, every time you want to do a stem and leaf diagram, you should first look at outliers. And if you look at these values, the smallest is a 2, but then you have a 6, an 8, an 8, and the maximum is a 35. You don't seem to have any outlier. Next step to get a stem and leaf diagram, you have to know how many branches you are going to have. So it ranges from the units until the 30s, so you have a total of 4 branches. And then for each one of these branches, you have the individual leaves, and you would have something like this. You have a total of 21 times measured. This, something like this, would represent 5 people, and here you have 1, 2, 3, 4. No, it's a total of 4 branches. As I mentioned 5, but it's 4 that I meant. Okay, and then for each, you have here the individual leaves. This will be it. No, I want this one. Find the median, the lower quartile, the upper quartile, and the interquartile range using the stem and leaf diagram. So the median, you have to use a formula, which you already know is n plus 1 divided by 2. This would point out to the 11th position. So start counting over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's this, 19 people. That's the median. The first quartile, you just do n plus 1 divided by 4. This yields 5.5, so you have to look at the 5th and the 6th position. 1, 2, 3, 4, 5, so 8, and 6th, 12. The average of this is 10 people. For the third quartile, it's 3 n plus 1 over 4. This yields 16.5, so we're looking at the 16th and 17th position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17th. 16th is 23, 17th is 25. The average of this is 24 people. The interquartile range, that's Q3 minus Q1, so it's 24 minus 10, 14 people. And that will be it for this sub-question. Finally, state, in this case, which of the median and the mode is preferable as a measure of central tendency and why. So we already calculated the mean, the median. It was 19 people. We just need to get the mode. The mode is just a matter on a stem and leaf diagram to see, look at the leaves and see repetitions and see where you have the biggest repetition, and it's obviously here. All right, so that corresponds to the 23. So which one do you think is the best measure of central tendency, the 19 or the 23? If you look how this is distributed, the 23 is too much pushed to the end over to this side, isn't it? You just have 1, 2, 3, 4, 5 values after that. The 19 seems to be more at the middle of the values that you have over here, right? You have all of these before, and you still have all of those after. So I would argue that the median is better as the distribution is slightly skewed, and the mode falls off a little from the center of the data. So particularly this last point would be enough for me to pick the median instead of the mode as the best measure of central tendency.